More applications on the first derivative of the quotient of two functions. Find the points on the curve y equals 2 minus 5x over x plus 3, where the tangents to the curve at this point are parallel to the line y equals 2 minus 17x. The tangents to the curve are parallel to the line y equals negative 17x. Parallel lines have the same slope. The slope of this line equals the coefficient of x, so the slope is negative 17. This is equal to the slope of the tangents to the given curve. We know the slope of the tangent to the given curve. The slope is represented by the first derivative at the required points. So let's find the first derivative of the given curve. Write an equation and solve to find the required points. The function represents the quotient of two functions. So the derivative equals the derivative of the numerator times the denominator. So derivative of 2 is 0 minus derivative of 5x is 5 times the denominator x plus 3 minus the derivative of the denominator is derivative of x is 1 and plus derivative of 3 is 0, so 1 times the numerator 2 minus 5x, and down we have the square of the denominator, so x plus 3 squared. Simplify, this is equal to negative 5x and minus 15, 5 times 3 to be 15, and minus 2 and plus 5x over x plus 3 all squared. This is equal to, simplify, negative 5x and positive 5x cancel each other, and negative 15 minus 2 is negative 17. Negative 17 over x plus 3 all squared. This is the first derivative, y dash, of the given curve. This is equal the slope of the tangents to this curve, which is equal to negative 17. So this is equal to negative 17. Now we have an equation. We cross product, move this up. So negative 17 equals negative 17 times x plus 3 squared. So negative 17 equals negative 17 times x plus 3 all squared. Divide both sides by negative 17. So the negative 17 is cancelled. So x plus 3 squared equals 1. Now expand the perfect square binomial. X squared and plus 9 plus 3 squared to be 9, and plus the first times the second times 2. So 3 times 2 to be 6 times x to be 6x. Move the 1 to the other hand side with negative. This is equal to 0. So x squared plus 6x and plus 8 equals 0. X squared means x times x. 8 means 2 times 4. We have positive signs, so the two signs will be the same. Take the sign of the middle term for both signs. So x plus 4 times x plus 2 equals 0. So if x plus 4 equals 0, so x is negative 4. And if x plus 2 equals 0, so x is negative 2. Use the original equation to find the corresponding y values. The original equation is y equals 2 minus 5x over x plus 3. At x equals negative 4, y is 2 minus 5 times negative 4 over negative 4 plus 3. This is equal to negative 22. So the first point is negative 4 and negative 22. And at x equals negative 2, y equals 2 minus 5 times negative 2 over negative 2 plus 3 to be 12. So the second point is negative 2 and 12. The required points are negative 4 and negative 22 and negative 2 and 12. Find the equation of the tangent to the curve of the function fx equals 1 over x minus 1 at the point 2 and 1. To find the equation of the tangent to the curve, we need to find the slope of the tangent. The slope of the tangent equals the first derivative of the given function at the required point. So let's find f dash of x. We have a quotient, So the first derivative equals, take the derivative of the numerator times the denominator, that gives 0 because the numerator is a constant, so 0 minus the derivative of the denominator is derivative of x is 1 and minus 0 times the numerator which is 1. So we have negative 1 up and down, it's x minus 1 all squared. So this is equal to negative 1 over the square of the denominator, so x minus 1 squared. This is the first derivative. We want the equation of the tangent at the given point where x is 2. So find f dash at x equals 2. Substitute 2 for x. So this is equal to negative 1 over 2 minus 1 to be 1 squared to be negative 1. The first derivative at the given point is negative 1. So the slope of the tangent is negative 1 and the tangent passes through the given point 2 and negative 1. So the equation of the tangent will be, so y minus the y value of the given point, so y minus 1 over x minus the x value of the given point, so x minus 2. This is equal to the slope. Cross product and find the equation. So y minus 1 equals, multiply this times negative 1 to be negative x plus 2 and move the negative 1 to the other side. Therefore, y equals negative x plus 2 and plus 1 to be plus 3. This is the equation of the tangent to the curve of the given function at the given point.